So really appreciate the invitation and the opportunity to speak this morning. Just to make sure I can. So I think I have to wait 7 seconds on this slide, which it takes away some time. But I won't really be discussing many of these. Oh yeah. Oh, good point. All right. So often I'm asked this faced with this conundrum, which is, there has to be a better way, and increasingly that answer is the answer to that question is just use AI. Just throw AI at it, which drives me a little crazy. But I think that this really is a reflection of something that happened between October of 2022 and November of 2022, and that was the accessibility and use of an agentic AI system, ChatGPT. And I'm not going to go too far into this because I think now, 2 years after its release, many of you have interacted with this or used different forms of this. But fundamentally, what ChatGPT is, it's an AI system. And what's critical about that is that it's powered by at least two multimodal, at least input models that are large language models, either GPT 3.5 or 4, depending on the tier that you use. And the key here is that they provide the ability to interact with this AI system through natural language, conversational AI. And just to take a step back, what is a large language model? I think it's important to kind of level set. These ultimately are models that are derived and created to predict text. And how that works is that it's moving these tokens that the text is derived into a feature space, a numeric feature space that ultimately can be used for prediction. It provides the context and capability for understanding language, to generate coherent and contextually relevant text, and also provides interactivity. So really unique features of this class of models. What's interesting about large language models is that they feel new right now in this era, and this is in large part because of just the progress made in training on the number of parameters that they're trained on. And when I started studying language models, at that time we didn't really call them large language models. This is pre-2022 in the BERT type era. It was, while prompting and some of these ideas that we can now actually interact through natural language with systems were just kind of coming to fruition. There's so many LLMs out there. Just yesterday, I think Meta released Llama 3, kind of this next generation open access model. But why we don't talk about a lot of these other model types, I think, is in large part because of this interaction. So what makes large language models so unique is the ability to take a human and AI system and allow them to interact in a way that was previously very challenging. And LLMs facilitate this through, again, interactivity through natural language. So just a tangible example of how that actually looks, which this is like the most simplistic prompt ever, and I'm kind of embarrassed putting it up here. But so can you make a picture of a human interacting with AI, depicting how they talk to one another? So when you use ChatGPT or any of the commercially available interfaces, what's happening is that you're leveraging GPT-4, which is the large language model. What it recognizes is that this prompt is looking for an image completion and then passes that prompt to a separate transformer-based model, DALL-E 3. That's an image generating model, and then that subsequently leads to outputting the image that you're requesting. So again, it's not a single model that's deriving the ChatGPT interface, but instead interacting through natural language via an LLM to produce the output. And I think this is really critical because when we think about using large language models in surgical practice, it really is about agentic AI systems. How do we work with AI as humans to get value out of what the AI system is providing? I'm going to provide two kind of tangible examples, pain points, so to speak, areas where LLM-based solutions might be useful, already have been shown to be implemented, and then we're going to kind of uncover how they work, what actually is happening under the hood, so to speak. So the first is clinical documentation. I think it's no secret that clinical documentation is a pain point. A lot of time and effort and energy spent on the EHR, putting information in. These are kind of old studies now, but still very relevant, where internal medicine residents spending over 100 hours a week on clinical documentation, majority of a work week in family medicine being used on documenting into the EHR. So clearly, an opportunity for improvement. These are the images that often are associated with, medicine in kind of modern day. But, maybe this could be the vision. Again, this is another AI-generated image, potentially putting an AI agent in the room. Look at how gentle and kind that AI system is between the clinician and the patient, potentially augmenting and helping support this interaction through large language model-based system. So already these are out and in play. We use DAX Copilot at our institution. Microsoft, through their collaboration with Nuance, AWS has a tool set, Suki. So there's many different clinical documentation tools out there that are slowly being integrated and implemented into real-time clinical practice. And when you think about this workflow from end to end, there's some things that need to happen. Obviously the conversation, the audio needs to be captured, that audio needs to be diarized, and then subsequently there needs to be speech recognition on top of that transcript that needs to be extracted, and that needs to be turned into a clinical note. We do audio pretty well. If I said, "Hey Siri," many people's phones might start beeping. The diarization speech recognition part, getting better. But where the big challenge has always been is going from that speech and then actually extracting it and summarizing it into something usable. That's where the large language model comes into play, especially with the advances that we've had now, which is that ability to recognize human text and summarize it in a way that fits what's actually happening through contextual cues is actually what allows these systems to be effective. And this is a study out of the Kaiser group earlier this year where they implemented an ambient AI scribe. And what they found was in this study, this is just looking at user uptake, very quick adoption. They offer this to about 4,000 physicians, so the top edge of that y-axis. And within a month, nearly all of those physicians were using it. And the one area where there was an improvement, a very clear improvement, was time in the notes per appointment, where this graph is a little odd, but as the up means less time. So it showed that there were some efficiency gains through this system. So this is something that's really near and dear to me, and I'm sure all of us, which is OR case length prediction. We know that the operating room is important. It's a limited resource, and scheduling is a big part of ensuring that resource is used efficiently. If you go over with the predictions, it's a problem. If you go under with the predictions, it's a problem. So being able to accurately predict case length, very important. This is actually data from our institution. Epic is terrible at making case length estimates. This is accuracy that we've defined as within 20% of the actual case length. None of the specialties are over 50% accurate. So just, again, emphasizing a real opportunity to potentially leverage a different tool set clinically to make some improvements. So this is work from our lab, very pilot type data, but actually just shows a capability of large language models that we think is really useful and potentially will help augment agentic AI systems. What we were interested in was just, can you use zero-shot learning from GPT-4 to predict, using all the notes a year prior to a surgical case, to just say, hey, what would this case length be estimated to be? And from our initial data, small subset, but just shows a capability that may be worth exploring over time, which is that basically that single prompt through zero shot, again, no pre-training of this large language model, was able to predict with the same accuracy what Epic was able to produce. And what is happening kind of under the hood here is that you take all of these notes that are summarized for that year prior to the operation, and what the large language model is doing is it's predicting, based on that information, what should come next. So the possible outputs being the various times, and then those resultant probabilities. And then ultimately the decision of which output to use is based on 3 different parameters. So how this would be integrated into an AI system, physicians entering information at the bedside into patient notes. Those notes then are used directly to make the prediction via the large language model. That prediction then goes to the OR scheduler, and now you're able to bill your case length. So there has to be a better way. That question will keep coming up. And I'd propose agentic AI as the way to do it. And just some key takeaways as you kind of think about how LLMs fit into surgical practice. Thanks.